We move over to characters, where we have again signed characters and unsigned characters. If we see the same characteristics, it is again a character occupies 1 byte in memory and its range is from -128 to +127. Because it is a signed character, it has to represent both the negative as well as the positive values. The format specified for a character is %C, and this is the way you declare a character in C. When we move over to unsigned characters, it occupies the same memory space. Its range is double on the positive side, adding 128 to 127. Its format specified is %C, and it is represented as unsigned character is equal to the character that you want to assign. Now, if you will see, these are characters. Now, why are we specifying the range in terms of digits? This is because every character has its ASCII value. For example, we know that when we give the number 65, it represents capital A. So, each of these digits represent only a character in the ASCII table. So, that is the reason these characters ranges, the minimum and maximum possible characters that can be represented by a character data type in C are given in the terms of digits. Next, we have floats and doubles, which are nothing but data types in C to represent fractional values, that is decimal points. So, first we will see the float data type. The float occupies 4 bytes in memory, which is almost double that of a short integer. And the range of a float is expressed in the exponential form that we have seen in the last session, where the exponential form comprises of the mantissa and the exponent. So, if you will see, the range is specified in terms of the decimal values. The format specified for a float is %f, and this is how we declare a float data type in C. Now, the difference between the range of an integer and that of a float is that when we say the range of an integer data type, it means the lowest minimum value and the highest maximum value, and it is also used to represent all the values that occur in between these two. But in the case of a float or double, the range represents the lowest minimum and the highest maximum value that can be represented, but there are certain values in between these two that may not be represented by the float data type. So, that is the difference when we use the same term range for an integer and for a float or double. So, when we move over to double, it occupies 8 bytes in memory, which is double that of a float, and the range is also almost twice the values that can be represented by a float, and a format specified is %LF, which stands for long float, because if you see, double is nothing but a long float. Twice the amount of memory that is required for a float is required for double. And in double itself, we have the data type long double, which occupies 10 bytes, and this range is also much higher than that of a normal short double. And the way to declare a double is using double Y. Now, this double and long double values are generally used in exceptional cases in very large applications where large numbers need to be represented. Normally, when we write general programming operations in C, we go in for the usual integer data types, or when we use fractional values, we go in only for float. Obviously, because they occupy less memory, which makes programming faster, and the execution result is delivered at a much higher speed. So, this is about the data types that are available in this programming language C.